Okay, guys, welcome to virtual GED class. Today we're going over one of those Math 101 basics that you really need in order to understand the higher math that happens on the GED. That being said, a lot of teachers teach all the basics, all the fractions, all the decimals, all the percents, all the negatives, everything before they let you do algebra, geometry. Y'all know I'm not that style, but this is one of those things I just can't get away with, and so we are backing up a little bit, doing an intro to exponents to make a lot of our more complex concepts be a lot simpler as we go on. The first thing I want to do with this lesson is to link it to something that we already remember. So I'd like you guys to remember that repeated addition can be rewritten as multiplication. This is something we talked about last class, that one way to think about multiplication was as repeated addition. Let me give you an example of what I mean. For example, 7 plus 7 plus 7, I'm repeatedly adding the same number here. Could be rewritten. It is equivalent to a multiplication expression, and I bet David knows. What multiplication expression is this equivalent to?
5 times 7.
Absolutely. 7 times 5 or 5 times 7, same difference. I'm going to write 5. Oh, no, I think I will write 7 times 5. 7 times 5, the number 7 adding 5 times. So two ways to talk about that. So what I want to do is latch onto this new information. As it turns out, we have another operation that works like that. So last class we talked about the 4 basic operations. David was the only one with me last class. Reminds everybody what the 4 basic operations are, David.
Multiplication, addition, subtraction, and division.
Exactly. Addition, subtraction, multiplication, division, those are the 4 basic operations. Well, but they're not the only operations. In fact, the most humbling day of my math career was the day that I burst into tears in a university math class because they introduced a new operation I'd never heard of, and it felt so unfamiliar, and I went running out of class going, maybe I'm not meant to be a mathematician after all. So there's lots of operations. Today, the one we're going to do is simple, no need to cry. Okay, you guys? But we are going to learn about exponents. Okay, so we've got a new operation. They're called exponents, and they remind me a lot of this idea that multiplication is the same as repeated addition. So a new operation, exponents. What do you guys think of when you hear exponents? Anybody know what those are?
The power.
Yeah, you think of the word power? Absolutely. Exponents are definitely powers, are part of the exponents, okay? And so when you say power, do you have a visual of what that might look like mathematically, David?
7 with the power of 2.
Sure, those little floating numbers, a lot of times, those little numbers up in the sky. So David said 7 with the power of 2. Now let's talk about what that means. Basically, what exponents are a shortcut way to talk about repeated multiplication. So just like 7 times 5 means the same as 7 plus 7 plus 7 repeated addition, if I were to write 7 to the 5th power, that's a similar idea, but instead of repeated addition, an exponent represents repeated multiplication. So 7 to the 5th power is the same as 7 times 7 times 7 times 7 times 7. And you guys, it's disgusting. I'm not going to start multiplying. 7 times 7 is already 49. Times another 7? I don't know. Times another 7? Even huger. It's a big, giant number. So I'm not thinking about what it would be simplified right now. Right now, I'm just thinking about 2 different ways to write the same math expression. I can write it with an exponent, or I can write it as repeated multiplication. So we have some language you need to know. We have some language, okay? First of all, we need to know that this number with its feet on the floor, the big number, is known as the base, okay? The base tells you what number is multiplying. So in our case, 7 was multiplying. Then the little floating number up in the sky, that's superscript. Superscript, it's up in the sky. And that one is the power or exponent. It could be called either. And that tells you the number of times the base is multiplying by itself. Not adding, but is multiplying by itself. Okay, so 7 to the 5th power means 7 times itself. 7 times 7, 5 times. And you can see here we have 5 sevens multiplying. Okay. Okay. So one more thing I just need you to know, it's language. So all the time in class, my students say this interesting thing to me. They say to me, but what's the answer? But what's the answer? But what's the answer? And you guys say, but what's the answer? And I'm like, what, it depends what I asked you. The answer depends on the question. Am I correct?
Yes.
Okay, so you've got to be able to understand the question before you're going to be able to answer that super important to students question of what's the answer. Okay, so there's some language that shows up in the questions you guys need to know. So here's some terms I use. One thing you should know is I refer to this 7 to the 5th power written like that as the exponential form. So if I say write something in the exponential form, I'm asking for a base and an exponent. I refer to this over here, the multiplication, the repeated multiplication, as the expanded form. That's one word for it, or sometimes I'll call it the factored form. Okay, so I mean, I think it's kind of obvious why it's called the expanded form. So what does the word expand mean?
Bigger.
Yeah, to pull out or to draw out. I'm pulling out this exponent as repeated multiplication. So it kind of makes sense to me that it's called expanded form. Why is it called factored form? Well, when you're factoring something, you're looking at it as a product. You're looking at it as a multiplication problem. What numbers would multiply to make this? So factored form is saying turn it into a multiplication expression. So now let's look at some example problems. So you could be asked simply to write 1 to the 5th in expanded form. I love it because students say to me, what's the answer? What's the answer? Well, the answer is whatever I asked you for. I asked you for expanded form. Please just write it in. Expanded form. What does 1 to the 5th power mean when you write it as multiplication?
1 times 1 5 times.
Exactly. 1 times itself 5 times. So 5 ones multiplying. And a lot of you guys are such good, obedient students. I love you guys to death. You look at those multiplication symbols and you're like, I better start multiplying. Well, no, because I didn't ask you to. I just asked you to write it in expanded form. You're done. This is the answer. Okay? I don't know why GED students struggle with that so much, but we're done. And I could similarly say, write 2 to the 3rd power in factored form. Again, factored form means writing it as a product using multiplication. So the same idea here. I just want to rewrite this. How would I write this in factored form?
2 times itself 3 times.
Exactly. David's bored. It's so simple. Or I could flip it around on you guys, and I could ask you to write something that was in expanded form, and then ask you to put it into, what did we call the other form? Anybody remember?
Exponential form.
There we go. So if I'm going to write it in exponential form, remember I need a base and a power, or an exponent. What would my base be?
5 with the power of 6.
Absolutely. The base would be 5. 5 is the number multiplying. And how many times David saw it? 1, 2, 3, 4, 5, 6. So that's 5 to the 6th power. So just an FYI, the GED is not an arithmetic test. The GED is an algebra test. So you're very frequently going to see this show up, and maybe you see some letters get involved, and students will lose their mind. But exponents are exponents, regardless of whether I'm using numbers that I know or unknown numbers, variables. So let's look at a few more examples. I'm a little resentful of this problem. Why did I even make it up? I'm going to have to do so much writing, my hand is going to hurt. Okay, let's talk about this. I want you to write x to the 8th power in expanded form. And students say to me, but what is x? I don't know, and I don't care. I just want you to rewrite this expression pulled out as a multiplication problem. Now, careful. If I used a times sign with x's,
you're going to have to use the little dot.
That's going to look really confusing. Which one's an x, which one's a times sign? Which is one of the big reasons why David and I discussed last week. We just drop x's for multiplication when we hit algebra. David, what did you want me to use?
The little dot symbol, or you could just smush them all together.
I sure could. I could put little dots between them all to signify x multiplying by itself 1, 2, 3, 4, 5, 6, 7, 8 times. That is one legit way I could write that, but not the only way. David, how else did we talk about writing multiplication?
You can use the, shoot, what are they called?
I wish I could see your hands. Are you talking about these, David?
Yes, ma'am.
Parentheses.
There you go, parentheses.
I sure could. I could put all these X's in parentheses. This would mean the exact same thing. You say, which one's the right one? They're both right ones. And if this were on the GED, you'd either probably have a multiple choice. 1, 2, 3, 4, 5, 6, 7, and 8 X's multiplying. We last class, so for those of you who missed last class, Veronica and Nicole, I will be finishing the editing for last class and putting it up in our Canvas. So you'll be able to see it, okay? But last class, we said there was another way in algebra that we expressed multiplication. We didn't even need the parentheses. Did you remember, David?
Yeah, you can just mush it all together.
You could just mush it all together. If they're just letters, I could literally just mush them all together and say that they're all multiplying. Proximity means multiplication. 1, 2, 3, 4, 5, 6, 7, 8. All of these three say the same thing. I don't care which one you were to write. They would all be correct answers on the GED. So now I want you to write P times P times P times P times P in exponential form. And I always get the question, but what's P? And I'm like, don't care, don't know, don't care. Don't know. Nobody told me what P is. P is a big fat mystery. But I can still write this in exponential form. How?
P to the power of 5.
P to the power of 5. Whatever P is, he's multiplying by himself 5 times. So let's clear this, and I want to introduce you to 4 special exponents. If you are taking notes, and I highly recommend you take notes, give yourself 2 or 3 lines for each number here, because I'm not going to talk about them in the order that they appear in your notes. I'm going to kind of mix up the order a little bit. Okay, so I want to talk about 4 special exponents, 0, 1, 2, and 3. So I'm calling these exponents. So I'm talking about when these numbers are floating in the sky. Okay, I'm talking about when they're up and their powers. So the power of 0, the power of 1, the power of 2, and the power of 3. I'm going to put a line between them because they're special for different reasons. Let's talk about 2 and 3 first. 2 and 3 are simply special because they have nicknames. Now I use the term nickname loosely. I shouldn't. It's not really a nickname, but they have short ways to talk about them. Mathematicians are like the laziest people on earth. No joke. They really are. We're always looking for a short way to do things. And when you write something like this, I get a little resentful of how I'm supposed to say that. I am supposed to read that as 7 to the 2nd power. Be really careful. Don't say 7 2. That means something else entirely. Okay, if you said that, I would correct you. This is 7 to the 2nd power. Now, I don't want to say that. It's really long and it takes a while to say, and I'm a lazy human being. So we kind of have a nickname. The power of 2 comes up so much that it has another name. We call it squaring. So that can also be read as 7 squared. We're going to say 7 squared, like squaring is a thing we do. Squaring is a thing we do. It is an operation. You can square a number.
Yep.
Okay. Now, why in the world would I call this squaring? What in the world does it have to do with the shape squares? Well, it actually has to do with the area of a square. You know, if you look at a square that had a side length of 7, it would be 7 units that way and 7 units that way for a total of 7 by 7 or 49 units. Does that make sense? So when I say 7 squared, I'm saying make a square with a side length of 7. And it would have a total of 49 units within it. Okay, and the way I remember it is it's a 2D shape, a square, and we see that little floating 2. Okay, wonderful. So then let's talk about this. Obviously, I could read this as 7 to the 3rd power. But once again, I'm a little resentful. It takes a while to say, and 3's come up a lot. And so we have a nickname for that one as well. A little floating 3 is known as a cube. So this is 7 cubed. As if cubing is a thing I do, and it is a thing I do. Cubing a number, that's an operation. So why would I call it a cube? Well, a cube is kind of like a square, isn't it? Except a cube is 3-dimensional. If I say something 7 cubed, that means not only is it going out length and a width of 7, but it also has a depth of 7. It's a 7 by 7 by 7. It's a 7 cubed. And I remember that the little floating 3 is a cube by remembering that a cube is a 3D shape. Okay, let's move on to the other two. Now, 0 and 1 are special because of their behavior. If I talk about 7 to the first power. A lot of students not quite sure what to do because, I said that exponents, we rewrite it as multiplication, and yet if I just have 1 7 multiply, what is 1 7 going to multiply with? 1 7 is just a single solitary 7. There's nothing to multiply with. So 1 7 is just 7. And I feel like this makes sense to us because we're really used to 1 being a WIMP. I never have students who struggle with this because you guys are used to when you multiply by 1, nothing happens. When you divide by 1, nothing happens. So you're like, of course, when I raise to a power of 1, nothing happens. Makes sense. And so most students find this one intuitively easy to understand. So I joke around that 1 is a WIMP. 1 does jack. It's really important that you guys realize this because a lot of times I can fake you out or freak you out using gross numbers. For example, I could make my number really, really large and give students a heart attack. But what is 2,934 to the first power?
It's 2,934.
Exactly. Nothing changes because the first power does nothing. I can also freak my students out by bringing up the dreaded fractions. Everybody's panicking, losing their snot, puking on their toes. Oh my God, it's a fraction, and not even noticing that I raised it to the first power. What happens when I raise something to the first power? Well, nothing. That's still 2/3. Did I freak anybody out with my parentheses? So just to let you know, Nicole, I used parentheses there because I wanted to say the entire fraction to the first power. Wonderful. Now, the other way I can usually freak students out is by introducing a variable. Everybody's freaking out and you forget what the first power does. So x to the first power would just be?
X.
X. Good. So I don't care how ugly it is, the first power does jack. So now if the first power is intuitive, the 0th power is the one that's not intuitive. And I need you guys to watch out for things that are not intuitive in math. This one never makes sense to students at first. And in fact, I can't even explain it until we get to higher math, why it works this way. And so you guys will be like, what? 0 does not do what students expect when we raise things to the 0th power. So I want you to highlight this, start in your notes, because whenever I ask you to believe something just because I told you, your brain will say, no, didn't make sense. I don't want to remember it. So super important. You're going to need to review this in the future. Okay, so anything to the 0th power. Students tell me all the time, Kate, it should be 0. And I'm sorry, it's not. It's not. Anything to the 0th power is 1.
Yeah.
Yep, you knew that, David?
Yeah.
Cool. Okay, so put that in your notes because it doesn't make a lot of sense to us unless we've learned it before. And so you will be very likely to forget it if you don't repeatedly practice this. Okay, so anything to the 0th power is 1. So I don't care how big it is. 2,934 to the 0th power is just 1. I don't care how ugly it is. 2/3 to the 0th power is just 1. And I don't care how mysterious it is. X to the 0th power is just, Nicole, is that cool with you?
Not cool, but I'll live.
Can you see how it doesn't make sense? There's a real reason for it, I swear to goodness. But you won't see it until, I'm actually going to show it to you at the end of this lesson. But because it's not intuitive, yeah, it is easy to forget. So I would highlight that in my notes if I were you.
Highlighted in pink.
I'm going to erase this page, and now I'm going to talk about simplifying. We have not done any problems yet where we have just simplified. I have asked you to flip back and forth between the exponential form and the expanded form, but we haven't done what students think of as the answer for most of these problems yet. Okay, so how do I know that they're looking for the answer? They're looking for you to do the work. Well, there's a few ways, okay? If they want you to simplify, they will probably either tell you specifically, simplify, they may say evaluate, or they may just prompt you with an equal sign. And that's kind of this idea that students, when they say to me all the time, but what's the answer? So for example, someone might say to you, simplify 2 to the 3rd power. Okay, now they are asking me to do the math, but I have to warn you, students usually tell me 6. Students who just skip straight to the answer with exponents usually flip into multiplication instead of dealing with exponents. Now, I agree with you that 2 to the 3rd power has something to do with multiplication, but it's not the problem 2 times 3. So a really good rule of thumb is to rewrite in expanded form before simplifying. Okay, so let's rewrite this sucker in expanded form. How did we say that that 2 to the 3rd power would look if it was an expanded form?
2 times 2 is 3 times.
Exactly. Not 2 times 3, but 2 times itself 3 times. And if I were to simplify something like this, 2 times 2 is 4. And if I were to multiply that by the last 2, of course, I would get 8. I'm about to be a brat and see if I can intimidate you. 117 over 3 raised to the first power. What would I get?
17 over 3.
Thank you. The first power does jack. So I might say simplify. I might say evaluate. They both mean perform the operation, okay? But I could also say just prompt you with an equal sign, and nobody's usually very surprised with this. This is what we're used to, but let's see if I can be particularly mean. What is z to the 0th power?
1.
Nicole, you highlighted that in your notes, didn't you? Good girl. Yes, absolutely. It's 1. Okay. Anybody mad at me?
I will never forget that.
Question.
Yes, sir. What's your question?
So number 2,
Mm-hmm.
if it says simplify instead of evaluate, you're going to want to simplify the fraction, right?
It is a simplified fraction. So unfortunately, because of the way most 3rd grade math teachers teach, most students think that you're not allowed to have an improper fraction. Is that why you want to do something with this? You're looking at the top of that fraction and saying, oh my God, dear Lord, it's 17.
Yeah.
Yeah. So your 3rd grade teacher was a liar. I mean, I'm sure she was a sweet woman and gave you chocolate chip cookies. And I think that she was probably very lovely, but she didn't have a very deep understanding of mathematics. We are totally fine with improper fractions in high school and college math. In fact, we generally prefer them. The only reason your sweet 3rd grade teacher didn't want you to use them is because sometimes students struggle to understand what 17/3 means. Conceptually, to you, 5 2/3 makes more sense. Oh, 5 whole things and 2/3.
Yeah.
But no mathematician worth his salt has any problem with 17/3. It does not need to be converted to a mixed number to be simplified.
Okay.
Now, it does need to be reduced to lowest terms. That's another thing Miss Carson taught you, or whatever her name was, okay? And that is definitely part of simplifying. So if these two, like, for example, that one doesn't have one, but I'll just come over and bring one over here. David, if this was the thing and it said simplify, you're right. I would have more work to do after finding the first power, because this fraction is not reduced to lowest terms.
Okay.
Does that make sense?
Yes, ma'am.
Okay, so reducing is part of simplifying, converting to a mixed number is not. Am I clear?
Yep.
And Nicole, if that whole thing just blew past you, do not worry about it, because fractions are a very little portion of the GED. Okie dokie.
I can simplify. That's what I thought we were talking about.
Oh.
I was like, I know this one.
Well, good, because I'm never going to teach that. I'm glad you know it already. Okay.
Great, but I know number 3.
Yeah. Oh, good. Yes, you did know number 3. I was excited for that. Yeah. Well, I'll put the answer to that one anyway. So that one would have been 4/3. Okay. So Nicole can be justified. She's like, hello, I could do that. Okay. So I have 1, 2, and 3. I just wanted to try a few more because sometimes I signal things in words and you guys don't realize it. Probably I wouldn't say 5 cubed is. Probably I'd say what is 5 cubed. That makes more sense. Okay. What is 5 cubed?
5 to the 3rd power.
It is 5 to the 3rd power. But there is implied simplification in this problem, and that's what I wanted to point out to you. When you see what is in math class, I'm asking you, it's like the word is like an equal sign. So I am implying here that I would like you to figure out what 5 cubed is equal to. So I just wanted to make sure that I clarified that with you. So I'll write down 5 cubed first, but I am going to simplify it. I'm going to do the implied math. Okay, now we know that 5 cubed, I begged you before you simplify, you should write it in expanded form. So 5 cubed is the same as?
5 times 5 times 5.
And I know David sounds a little bored. He's like, Kate, why are you making me do this over and over again? And that's because most students, I'm just teasing you, most students tell me that 5 cubed is 15. And yet there's no way, because just 5 times 5 is already 25. And if I multiply by another 5, well, I've got something huge. Let's count by quarters. 25, 50, 75, 100, 125. So because I did say what is 5 cubed, that does imply that I would like that equal sign. I would like you to simplify, find out what the answer is, as GED students very frequently call it. So how about this one? What is 13 squared?
It's 13 to the power of 2, so 13 times 13, which is a big number.
Yeah. So how could I figure out that big number? If this was on the GED just this simple, you would not have a calculator. So super important, you could come over here and use your multiplication algorithm, and I will. 3 times 3 is 9, and 3 times 10, of course, is 30. So that's a 3 in the tens place.
169.
Yes, it is. And 1 times 3, or 10 times 3, I should say, is 30, and then 10 times 10 is 100. And you guys probably are saying, why is she saying 10 times 10? Is that a 1 times 1? I have this like pet peeve about people not understanding place value when they multiply, and then they make dumb errors. Okay, so I get 169. So what is 13 squared? Well, simplified, it's 169. So everything we've done so far would be on the non-calculator section of the GED. When you guys go to look at the practices I have associated with this, if you're doing this style of problem, you should be doing them by hand, no calculators. Make sense?
Yep.
But what we've done today with the expanded form actually applies to the algebra on the GED as well. Now, I'll be talking about these concepts later, algebraically, using some math language, but for today, I just want to use the one tool we have, the expanded form, to figure out all kinds of complicated looking problems. Let's see, what shall we title this? Let's call this Using Expanded Form to Simplify Exponential Expressions. Now, math teachers have a pretty bad habit, not all of us, but a lot of us, of writing all these rules on the board, asking you guys to memorize all these rules, and you guys get all the rules mushed together and do weird stuff. Has that ever happened to either of you guys?
All the time.
All the time, right? You're just, your rules, you're like, what rule is it right now?
Yeah.
So I am not going to teach you 3 of the most important rules of math right now. I'm just not even going to teach them to you. It'll be for another video. Right now, all we're going to do is some problem solving using expanded form. Okay, so here we go. Let's look at an example. The directions on a problem like this might say something like simplify, express your answer in exponential form. Now, simplify is just such a generic word in math. It kind of means do the math you can do. So here I have 2 to the 5th power, and I have 2 to the 3rd power, and I have no rules memorized, and I have nothing except for the expanded form. And so what I'm going to ask you guys to help me do is just use the expanded form to write these things out to see what would happen. So let's just look at 2 to the 5th power. What does that piece or part of this expression mean? What is another way to write 2 to the 5th power?
2 times 2 times 2 times 2 times 2.
Good. So I just wrote 2 to the 5th power another way. Totally legal in math. Anytime one thing is equivalent for another, you can trade them out. Now I want to talk about this part of the expression. What do these parentheses mean?
It's making it multiplying.
It's making it multiply. So that is going to multiply. I'm using another thing for multiply, a dot. Is everybody cool with that?
Yep.
With this. And what does 2 to the 3rd power mean? Help me write that out in expanded form.
2 times 2 times 2.
There you go. I've just taken everything I saw from above and wrote it into a form that I understand more. And now I think that I see something interesting. All I see here is 2's multiplying. Do you see that?
Yes.
Yeah, but would you keep the parentheses or not?
Good question. Do I need them? Well, the good news is, and this is another property that's not necessarily on the GED, but there's a property known as the associative property, which says when you're multiplying, the groupings don't matter. It doesn't really matter how you group it. You're going to get the same answer in the end anyway. So no, because it's all multiplication, I don't need the parentheses. Does that make sense?
Yeah.
Now, if I had some other operations in there, David, add, subtract, now maybe the parentheses would matter. I wouldn't be able to just drop them. But since it's all multiplication, they don't matter a bit. You cool with that?
Yeah.
Okay, wonderful. So there it is. I still have only 2's multiplying. So if I were to express my answer here in exponential form, it's some number of 2's multiplying. Well, how many 2's? 1, 2, 3, 4, 5, 6, 7, 8. 8 2's multiplying. Then let's graduate to algebra. Y'all ready? I got faith. I want to, again, same directions. Assume it said simplify. Express your answer in exponential form. Okay, so before I jump to exponential form, some of you guys might see the shortcut already. I'm going to write it out in expanded form, okie dokie? So let's start with this expression. X to the 4 means the same, fourth power means the same as what?
X multiplying by itself 4 times.
Bingo. And similarly, these parentheses mean what?
Multiplication.
Multiplication. And now I see the other expression I'm multiplying by is x to the second power, which means the same as?
X times X.
X times X. And now I can see all this is a bunch of X's multiplying. How many X's multiplying is it?
6.
X to the sixth power. Anybody see the shortcut?
Yeah, you just add the powers.
Oh my gosh, David, you've just derived what's known as the product rule. When multiplying like bases, add the exponents. I won't even write it down.
But if they're
I'm
different
not your
bases?
college algebra teacher, but that's the shortcut. What did you say?
But what if they're different bases, like 2?
Oh, I wouldn't be able to do it. I just wouldn't be able to put them together.
Then that, in that case, you'd keep the parentheses, right?
Like if it said p to the fourth times q to the fifth,
Yeah, you can't do
I'd say, oh, that's p to the fourth q to the fifth.
That's the answer.
I don't necessarily need the parentheses because I could just shove them together to say they're multiplying, but you're right. I couldn't talk about them as the same thing because they're not.
Okay.
That's a good question. I have never talked about that in this lesson before. You're really bringing it up to a higher level, sir. So then let us look at another application. So let's try this. Let's try 3 to the 8th power over 3 to the 5th power. Now, interesting, different, obviously not the same as the last problems where I was doing like 2 to the 5th power times 2 to the 3rd power. Now I have it over. But David, we talked about this last class. What does a fraction bar mean?
Division.
Division. Okay. So I'm asking you this time to take 3 to the 8th power and divide, not multiply, by 3 to the 5th power. Okie dokie. Again, I got nothing at my disposal, no rules. All I've got is expanded form. So help me out. Let's write this sucker in expanded form. I think I'll keep it with the fraction bar. And I'm already feeling a little pissy about the fact that I should have wrote this problem nicer because I do not want to write 3 to the 8th power in expanded form. But I'm so dedicated to you guys that I will. Okay, so 3 to the 8th power means 3 times itself 8 times. My goodness, is that 8 of them? 1, 2, 3, 4, 5, 6, 7, 8. Or 8 threes multiplying. Okay, cool. And then 3 to the 5th power, of course, means 5 threes multiplying. So then I have a question. Do you know what happens when we have the same number at the top and the bottom of a fraction?
It's a whole.
Yeah.
Say that again. What did you say, Nicole? It's a what?
It's a whole.
It's a whole. It's one whole, right? 3 divided by 3 is just one whole thing. Or another way to think of it is it cancels, right? That's how we reduce fractions. That thing I said I wouldn't do on the last screen. We pull out. We basically cancel out when we have the same factor top and bottom. So I'm going to do this here. Well, the 3 on the top will cancel with the 3 on the bottom, and the same thing will happen here, and the same thing will happen here, and here. And here. And what will I be left with now?
3 to the power of 3?
Exactly.
Or you could just subtract 5 and 8.
See, it was you. Brilliant. I was supposed to do a second example before you started deriving rules, David. But thank you.
Sorry.
I'm going to do one more before I stumble upon his brilliant observation. Okay, let's do one with x's. Okay, x to the 5th over x to the 4th. Okay, let's write x to the 5th out in expanded form. Help me out, guys.
X times X times X times X times X.
Cool. And x to the 4th power, of course, would just be 4 of those x's.
Yep.
We realize that when we have the same factor on top and bottom of a fraction, they cancel. That's 1 for 1, 1 for 1, 1 for 1, 1 for 1. And I would just be left with a single solitary x. Now, David, did this follow the pattern you were expecting?
Yeah.
Yeah, x to the 5th. He said I could just subtract the exponents when dividing. Well, 5 minus 4 is 1. But as we know, x to the 1st power is just the same as x.
But we won't get in trouble if we add that little 1.
Such a good question, Nicole. I love it. Would I get in trouble, Nicole says, if I had that little 1? So, Nicole, you kind of would. Okay, that little 1 is, this is absolutely true. There is nothing, there's no lie here. And so mathematicians are really, really obsessed with truth. So we'd be cool with that. However, it is not simplified. A general rule of thumb is, unless asked otherwise, mathematicians will give their answer in simplest form. Since we know a simpler form than x to the first power, I would expect you to write it like that. Now, that being said, you wouldn't be wrong if you wrote it the other way. You would kind of be like a English major wandering around in the math major's universe. We would just know you're not from around here. Reminds me of like when a non-native speaker says something like, pretty is she? Well, grammatically correct, but a little weird.
Yeah.
So this last rule that we just did explains why anything to the 0th power has to be 1. Okay, so let's look. That was the one that Nicole told me she would never forget. Well, now I can show you why. Well, David just told me there was a shortcut. He said, Kate, if you were dividing like bases, so there I have my like bases, what did you say I could do with the exponents, David?
Subtract them.
Subtract them. So you're telling me that that must be the same as 5 to the 3 minus 3. And 3 minus 3, of course, is
0.
0. Okay. Well, anything to the 0th power we said had to be what?
1.
1. Now, of course, this has to equal 1. Let's back up to this original expression. I want to talk about when the top and the bottom of a fraction are the same. What's 17 over 17? Well, 17 divided by 17 is just 1, right? 17 divided by 17 is 1. How many 17s are there in 17? 1. And, 120 divided by 120 is just 1. So guess what? 5 to the 3rd power over 5 to the 3rd power, same number top and bottom. It better just give me 1. And that is actually why the 0th power has to give you a 1. And let's look at one more. And this is one messes with students a lot. So a lot of students will tell me this is a multiplication problem, but this is not a multiplication problem. Does anybody feel brave enough to read this? Do you know how to read this? It's definitely 2. This part is 2.
Oh, 2 cubed.
Okay, so 2 cubed. What is happening with that 4? Do you see how that 4 is up in the sky? I'm taking 2 cubed and I'm raising it to the 4th power. I'm taking something that already has an exponent and putting on another exponent. And once again, in order to see what happens, I would very much like to use the expanded form. No rules yet. Okay, let's do this one step at a time. Let's start with just this piece, the part inside the parentheses. 2 to the 3rd power. Help me rewrite that in expanded form. What would that look like?
2 times 2 times 2.
Now notice that 2 to the 3rd power was in parentheses. Do you see that?
Yes.
That means that whole thing is being raised to the 4th power. So I'm going to keep my parentheses here to say that this whole thing is being raised to the 4th power. Now I'm going to do one more rewrite. I have another exponent to deal with. So what does it mean if I'm going to write something to the 4th power? Well, it means I'm going to take that whole thing and multiply it by itself 4 times. So what I'm going to do is I'm going to take this times itself 4 times. I'm going to write 2 times 2 times 2, and then I'm going to multiply that by 2 times 2 times 2, which I'm going to multiply by 2 times 2 times 2. That's a 3rd time. And now here's a 4th time. I have written 2 times 2 times 2 4 times. Now, David, you asked me the question before, can I drop these parentheses? Take a look at this. Can I drop these parentheses?
Yeah.
Yeah, this is all just multiplication. The grouping won't matter. It's basically like I just have 2 times 2 times 2. Now, you probably don't want to rewrite out this whole line again. It, in fact, is making me a bit grumpy. But how many total 2's do I end up with multiplying?
7.
I disagree. Want to count those for me?
12.
12. David, I know exactly why you said 7, because if it looked like this.
I didn't multiply it. I added it.
Exactly. You were thinking about this problem. This is where they would add up. 2 to the 3 times 2 to the 4th. But that's not what this says. This says take 2 to the 3rd power and raise it to the 4th power. Does that make sense?
Yes, ma'am.
Okay, so I get 2 to the 12th power. Now I'd like you to take x squared and cube it. So let's again start in the center here. Help me rewrite x squared as in expanded form.
X times X.
Times X.
And now this 3 out here means that I'm going to take this entire expression x times x and write it 3 times. So x times x once, x times x twice, x times x 3 times. How many total x's will I end up with multiplying?
6.
6. Okay, David, do you want a shortcut now? What's the shortcut for this is known as the power rule, but
You multiply 2 times 3.
yes, when raising something that's already exponential, so an exponential expression, to another power, you just multiply the exponents. Now that you guys are, I told you I wouldn't teach you the shortcut rules, and then y'all were so brilliant, I just had to do it because you were stumbling upon them yourselves. So since we did do the shortcut, let's just sum up the 3 rules really quickly, and then we will end this video here. Okay, so we have the product rule. You do not have to know the names of these rules in order to pass the GED. You could always just do expanded form, just like I did on the last 3 problems, okay? However, in order to pass your college algebra classes, they will expect you to know these rules backwards and forwards. They love to just teach you the rules, okay? We derived them ourselves because we were so brilliant, but what happened? So let's talk about the product rule. So we learned the word product last class, David. Do you remember what product meant?
Multiplication.
Multiplication. So product means multiplication. So the product rule says when multiplying like bases. So can you guys see that I'm multiplying like bases? That's 5 to the second times 5 to the sixth.
Yeah.
When multiplying like bases, add the exponents.
Okay.
And why is that? Of course, because I already had 2 5s multiplying, and now I have 6 more multiplying. That'll be a total of 8 5s multiplying. Quotient rule. We learned the word quotient last class as well. What did we say that meant?
Division.
Division. So the quotient rule tells you what to do when you have exponential expressions dividing. When dividing like bases, it says, and I keep using this phrase like bases without defining it. Shame on me. What do you guys think I mean when I say like bases?
The same.
Yeah, they're the same. They're both 5s. Good. Okay, so when dividing like bases, we saw that it would just cancel out, right? 2 of those 5s on the bottom would cancel with 2 of those 5s on the top, so I could just subtract my exponents. So that would be the same as 5 to the 4th power. Cool. Now the power rule, it looks very similar to the product rule, but students mix it up. But notice I don't have like bases this time. This time I just have an exponential expression with another exponent. Can you see that?
Yeah.
Okay, awesome. So that's the power rule. It says when raising an exponential expression to another power, and what did we do with the exponents that time, David? Do you remember?
We multiply them.
We multiply. When raising an exponential expression to another power, multiply the exponents. So what would this one end up simplifying to?
5 to the 12th, or 12th power.
Again, you do not have to have these 3 rules memorized for the GED, but if you have them memorized, your problems will go shorter. You know, it'll be faster in algebra. You won't have to write it out in expanded form to figure it out every time. So the only way that this gets more complex here, well, it doesn't. I actually taught you through the advanced level, which I don't always do in the video. So Nicole, you haven't experienced this before, but whenever I do a lesson, I always give beginning level, experienced, and advanced level practice. You do not have to get up to the advanced level practice, but if you want to get your GED soon, that's the level you should, strive for. Okay, thank you for joining us in virtual GED class today. I am excited now. We're going to be starting a new unit on word problems, interpreting word problems. Probably the 2 biggest skills on the GED math test are algebra and interpreting word problems. And man, GED students struggle. So that is what we're going to be looking at next unit, and I can't wait, and I hope you join us. Till next week.